Hi, everyone. Welcome to the 40th Annual Newitt Lecture, and thank you very much for coming. I'm Emily, and this is Eleni, and we are the two departmental reps for chemical engineering. So the Newitt Lecture gives us the opportunity to celebrate the achievements of Dudley Newitt and also the role of chemical engineers in society. It's our great pleasure that John accepted our invitation to speak tonight. First, we're going to begin with a brief history of our department and the life and achievements of Dudley Newitt. Then Professor Neelay Shaw will be introducing John, who will be giving the Newitt Lecture, followed by a Q&A session, and then we'll be giving out the postgraduate prizes. So in 1912, the department formally opened, housed in the chemistry department of the Royal College of Science, and headed by Professor William Bone. Then in 1913, we become fully independent by separating from the chemistry department. In 1922, the Institution of Chemical Engineers, the ICHE, was founded, with two of the members of the department, Professor Hinchley and Newitt, as founding members. Newitt later goes on to be head of the ICHE in 1949. In 1924, Miss Lukovic becomes the first female student in the department and finishes at the top of her year. And then in 1935, we have the Chemical Engineering Society being formed, first presided over by H.A. Humphrey.
In 1936, Professor Bone retires after 23 years as head of department, and he's replaced by Professor Alfred Egerton. In the same year, he's conferred as an emeritus professor and awarded the Davy Medal of the Royal Society. In 1937, the first undergraduate degree in chemical engineering starts. Its structure reflects a view that chemical engineering consisted of elements of other subjects, with a top dressing of borderline subjects such as fuel technology, plant design, and works organization. 4 students enrolled at the time, and we've now come to a point where we welcome 120 students a year. In 1945, the department moved from the RCSU to the CGCU. In 1952, Professor Dudley Newitt becomes the head of department, replacing Egerton. In 1957, the Roderick Hill building is opened by Her Majesty the Queen Mother, and facilities such as a lecture theatre and purpose-built library allowed the department to expand its intake of undergraduate students. In 1961, Professor Newitt retired as head of department, and Professor Alfred Ubelod takes his place. In 1966, the ACE extension opened with 2 more lecture theatres, a pilot plant laboratory, and concourse area. In 1975, Professor Roger Sargent, who we're very pleased to have with us in the audience today, becomes the head of the department. Anita Bailey becomes the first female professor and first holder of the Kodak Chair of Interface Science. In 1977, the annual Newitt Lecture was established.
Then in 1987, the first MEng degrees are awarded. And in 1988, Bill Wakeham is appointed the 6th head of department. Then in 1996, our speaker tonight, Professor John Perkins, is the new head of department. And in 2000, Professor Julia Higgins becomes acting head of department. Then in 2001, it's Professor Stephen Richardson for head of department. And in 2008, Professor Andrew Livingston. Then in 2012, we see the opening of our carbon capture pilot plant, which we're very proud of. Yes.
So Dudley Newitt was born in 1894, and he started his career straight after leaving school by working as an assistant chemist for Noble Explosives in Scotland. We will see as we go along that throughout his life he had sort of a talent for controlled demolition. His career was interrupted by the outbreak of the First World War in 1914. However, this didn't stem the tide of his many personal achievements. He was awarded the Military Cross for his participation in capturing Samaria and the West Bank, for which he also was promoted to the rank of Major. After the war, he undertook a bachelor's degree in chemistry from the Royal College of Science, one of the original constituent colleges of Imperial, from which he graduated with a 2-1. So any undergraduates here in the audience, please don't despair too much about your 69%.
Newitt then went on to postgraduate research in chemical engineering and fuel technology. And then just before the Second World War, he was granted his first major teaching post as reader of high-pressure technology. During the war, he then served as the director of research for the Special Operations Executive, which was also known in the war years as the Ministry of Ungentlemanly Warfare. He worked on devices for scientific sabotage, such as one-man submarines, silent weapons, and ways of derailing trains. His department also supported operations such as sinking the Bismarck and demolishing the Norwegian heavy water plant, which just goes to show that chemical engineers are not only the best at building chemical plants, but also at destroying them. Also serving in the Special Operations Executive was renowned author Ian Fleming, who then went on to write the James Bond novels. So, based on this, it's rumored that Dudley Newitt may have been the inspiration behind the famous character Q. Then, in 1945, Newitt returned to the department and became the first Courtaulds Professor of Chemical Engineering.
In 1949, he was elected president of the IChemE shortly before becoming a professor in chemical engineering. In 1952, he became head of the Department of Chemical Engineering and Chemical Technology. During this period, he was largely responsible for the expansion and improvement of the department, turning it into the internationally recognized institution it is today. He also helped restructure the Students' Union in an effort to better accommodate overseas students. As a result of this, he was elected to be the pro-rector of the college, a post he held until his retirement in 1961. Over the course of his career, Newitt greatly influenced the entire profession of chemical engineering. This is perhaps best appreciated by considering the professors trained by him, amongst whom can be counted Professor Coulson and Richardson and Professor Roger Sargent, which are names that certainly are new to anyone in the audience. We would like to invite now Professor Nilay Shah, who will introduce our speaker for today.
Thank you. So, welcome everyone, and thanks very much for giving me the opportunity to say a few words about John. John, I think for most of you, doesn't need much introduction, but I'll tell you, give you a short potted history, and refer to my 3 pages of notes here. So John, many of you probably know, is actually an undergrad from this department. He joined the department in 1968, and in the late 60s and early 70s, he was actually the president of the ChemEnSoc. So he knows exactly what's involved in running the Student Society. So he finished his BSc here. Of course, he got first-class honours and the Hinchley Memorial Medal, and carried on for his PhD studies, which he finished, and then he had a change of direction, maybe wanted to try something new, so he went to Cambridge for a while, but fortunately saw the light, and he came back again in 1977, became a lecturer, was promoted to senior lecturer, probably got itchy feet again then for a while, so he took up a very interesting opportunity, which was a professorship in Australia, which was jointly funded by ICI, and it meant he spent half his time at ICI Australia and half the time at University of Sydney. So he came back to us, and he became the director of the Centre for Process Systems Engineering around 1992, and he brought back lots of interesting new problems that none of us had heard about, which were around the area of mineral processing, and he used that to also motivate a lot of interesting control and integrated design and control research topics, which, although are very generally interesting in chemical engineering, there were some very interesting design and control problems in mineral processing. So while he was working on that research, he also successfully grew our research centre and got it to a point where it could run sustainably, which is one of his big challenges, because it was something that was funded by a big central block grant which was coming to an end. And that was my first time to really learn some very useful leadership-related things from John, which was around always having a strategy and a long-term plan for something you believed in. So he saw this centre funding coming to an end, and he put in place this very well thought out strategy for how we're going to not just maintain it, but actually grow it and putting on a footing that's sustainable for the long term. And that's what he left us in our centre, and for which we're extremely grateful. He moved on to become head of department, and during that time, his potential was spotted by the then rector, who had lots of interesting ideas for shaking up Imperial, one of which was creating the concept of faculties, which was not necessarily the most easy and popular thing at the time, because Imperial was a place where departments were the all-powerful thing. So I guess he had to think extremely hard who would be the right sort of person to run the first, to be the first head of the Faculty of Engineering, and he chose John, and I think, again, that was an excellent choice, because that was not an easy job at the time. But John, of course, went on to be a great success with that very difficult thing that he had to do there. So he became principal of the Faculty of Engineering, which he carried on doing till 2004, and then he moved on. You know, John doesn't mind a bit of a challenge, so this new challenge came up. I would say probably twice as difficult, which was at that time Manchester University and UMIST, which were two separate institutions, were going through a plan for a merger. And that meant bringing together some departments that had not worked together for a long time and were in separate universities, particularly the physical science departments, but also some of the engineering departments. And so John's job in Manchester was vice president and dean of the Faculty of Engineering and Physical Sciences, with a job of trying to make sense of this new merged entity which operated off two campuses with two different types of departments with different histories. And that has really, again, been a great success, and you can now see how Manchester has taken the lead in the Northern Powerhouse set of universities, which, again, is particularly because of its strength in this area of engineering and physical science. So then John, there's a trend here, because his next appointment was, again, something that was to build something more or less from scratch, which was something that I guess many of you have heard of, Mazda Institute of Science and Technology. So John was the first provost of the Mazda Institute of Science and Technology, which is an extremely ambitious new type of postgraduate institution, which not only was trying to set new standards in education, but also to set new standards in the nature of the built environment and the city itself to become a low-carbon demonstration centre. And so he went and set that up. And then he came back to the UK, where he's been doing a number of things. He's a visiting professor here. He's a professor at the University of Manchester. And he had a very interesting position recently, which was as Chief Scientific Advisor in the UK's Department for Business Innovation and Skills. So for his many services, he was awarded a CBE in 2006. He's been a president of the Institution of Chemical Engineers and vice president of Royal Academy of Engineering. So without further ado, I'm going to pass over to John. John is going to tell us all about 130 years of chemical engineering at South Kensington.
Thank you, Neil. Yes, thanks. It's a great pleasure and indeed an honour for me to be here this evening, so thank you for the invitation. My recollections of this lecture theatre are, surprisingly for me, more as a student than as a member of the academic staff. I can remember sitting in the back row. We sat in the back row of this lecture theatre, listening to lectures from Alan Cornish, who recently, unfortunately, passed away. The little fluid mechanics I know I owe to Alan Cornish, and it's not his fault that I'm not very good at fluid mechanics. It's just something that I've never quite got my head around. And who could forget Frank Leppington's mathematics lectures? I mean, he was an amazing lecturer and could bring mathematics very much to life. And of course, Henryk Savistowski, who, as Director of Undergraduate Studies, seemed to know the name of all of the 300 undergraduate students that we had in the department. So it's a great honour to be back here, and a great pleasure also. I'd like to make an apology to those of you who came expecting to hear a lecture from my younger brother. I really must update my photograph on the college website. My apologies for that. I'm going to talk in three parts about 130 years of chemical engineering in South Kensington. The first part will be about the 130 years. I've had a number of people come up to me and say, "Oh, you've got that wrong. The department opened in 1912. That's not 130 years ago. What on earth are you talking about?" So I'm going to talk about that first of all. Then I'm going to talk about some heroes of mine, and indeed I believe heroes of the development of chemical engineering. Key people, mostly from this department actually, who really contributed to the development of our subject and got it to where it is today. And then in the third part I'm going to talk a bit about some challenges and opportunities that chemical engineers and chemical engineering faces for the future. So that's the agenda. So let's start with the question of this 130 years. 130 years doesn't seem like very long, actually, when you realise that the civil engineers are just about to celebrate their 200th anniversary. So is it that South Kensington came late to chemical engineering, or is there some other explanation for that? Well, let's start by talking about chemistry. Chemistry actually is very much a late 18th century and early 19th century discipline, unlike physics, which has a much longer history. Of course, there were people practicing alchemy for many centuries before people like Lavoisier started developing modern chemical concepts. Indeed, Isaac Newton was a secret alchemist. He practiced alchemy quite aggressively, but didn't say very much about it. Rather a secretive man in general. I love this painting, actually. It's a painting of Antoine Lavoisier, but I like his attentive assistant who's standing there making notes and doing things. That, it turns out to be Eleuthère Irénée Dupont. Unlike Lavoisier, who didn't escape the rigours of the French Revolution, he was guillotined because he was a tax collector in his spare time. Dupont, of course, escaped to America with the recipe for black powder and founded the DuPont Company, and the rest is history, as they say. So chemistry really, late 18th century, first half of the 19th century is when the key early development in chemistry happened, which enabled the exploitation of chemistry more systematically in industry. And as we see here, this is a measure, this is plotting production of sulfuric acid and alkali in Britain between 1801 and 1881. You can see in 1801 the production was negligible, but by 1881 it was quite significant. So the industry really grew through the 19th century in response to the needs of the Industrial Revolution in this country. And it took a while for the industry to recognise that it had a few problems. This is a picture of Widnes, I think, in the 19th century. It was a very dirty industry in its early days, but it took a while for people to recognise that maybe a new class of professional was needed in order to do a better job of chemicals manufacture. So 130 years is not a short time, even though the civils are celebrating 200 years. Really in the 19th century that the need for chemical engineers was recognised and began to be addressed. So is 130 years too long? We've just heard that the Department of Chemical Technology, which is the precursor of this department, opened in 1912, I think. Yeah, in 1912, and that's less than, well, it's just over 100 years from today. So where does this extra 30 years come from? Well, to a large extent, they come from this man. This is Henry Armstrong, who was the first professor of chemistry in what was called the Central Technical College of the City and Guilds of London Institute. And this college was opened actually in 1885, opened to students in 1885, but founded in 1884. And it was founded because of concerns about the level of technical education in Britain in the second half of the 19th century. There was the Great Exhibition of 1851, not far from here, and a subsequent Great Exhibition in Paris about a decade later. And it was clear that Britain was losing ground compared to other developing economies at that time. And Gladstone took it upon himself to try and do something about this. And what he alighted upon was the city livery companies. He gave a famous speech, I think in 1875, if I'm not mistaken, questioning the point of having city livery companies these days. You know, what was the point of city livery companies? They had a lot of money, and they seemed to spend a lot of it on dinners and fine wines and things like that. They still do to this day, to my personal pleasure. So he convinced the city livery companies to come together and form the City and Guilds of London Institute, and in turn the City of Guilds of London Institute established the central institution. And in 1885, when the first intake of students happened, some of them joined a diploma in chemical engineering. So in 1885 in South Kensington, there was education in chemical engineering going on in the central institution. Interestingly, by 1888, when these students graduated, they were awarded a diploma in chemistry. So something happened between 1885 and 1888. And I'll be talking a little bit about the pressures on early chemical engineering and the need for some diplomacy and compromise throughout the history of the development of our subject. But nevertheless, Armstrong continued to be a passionate advocate of the application of chemistry in industry. And whilst the diploma changed its name, there was still a lot of engineering as part of that training. And that continued throughout the Central Institution's development, all the way up to 1907, when, of course, Imperial College was opened. So what about this name, chemical engineering, as it appears in educational establishments? Well, I think the earliest manifestation of chemical engineering happened in France, where there were ingénieur chimiste courses in many of the grandes écoles in the first half, actually, of the 19th century. And interestingly, Gustave Eiffel, of Eiffel Tower fame, actually graduated from École Centrale as an ingénieur chimiste. And I always think that the fact that he built the Eiffel Tower is just an early example of the fact that chemical engineers can turn their hand to anything. But I think building towers in France that last for as long as the Eiffel Tower is a pretty impressive achievement. I've talked about Armstrong in 1885. There was a similar initiative going on in Glasgow in an institution that was later to become Strathclyde University in 1888, led by Professor Edmund J. Mills. I'll talk more about George Davis in a moment. And then, of course, there's the famous Course 10, or Course X, at MIT, which started in 1888. So, arguably, South Kensington was at the beginning, in the English-speaking world, of chemical engineering education, and hence the 130 years of my title. I hope that justifies it, and that I'm not indeed wrong in my analysis. Now, I want now to talk a bit about George Davis, even though I struggle to find a connection between George Davis and South Kensington. He did actually study at the Royal School of Mines, although he never seemed to get a qualification from that study. He must have just attended lectures, I assume. Now, Davis is widely credited as the father of modern chemical engineering. And interestingly, he worked for a time as an alkali inspector. You remember the picture of Widnes that I showed you before? Eventually, government decided that they needed to do something about cleaning up the early chemical industry, so they introduced the Alkali Act and appointed a number of civil servants, alkali inspectors, who went around encouraging companies to clean up their act. And Davis worked for quite a while as an alkali inspector. He was active in discussions to set up a society of chemical engineers as early as 1880. There were a number of meetings of interested parties who seemed to agree that it would be a great thing to have a society of chemical engineers, and indeed a new profession of chemical engineer as a result of that. He gave a series of lectures in Manchester in 1888, and if you go to the chemical engineering department in Manchester, you'll see a big poster saying University of Manchester, birthplace of chemical engineering. This is arguable, as I would say. And he published his Handbook of Chemical Engineering, probably the first real textbook on chemical engineering, in 1901. Coming back to the Society of Chemical Engineers, by the time this organisation was formed, its name had changed from the Society of Chemical Engineers to the Society of Chemical Industry. And Davis was quite open about why this name change needed to happen. There were a number of academics, as he called them, professors of the professorial sort, I think he said, who were very nervous about this idea of a Society of Chemical Engineers. So to accommodate them, the name was changed to the Society of Chemical Industry. Again, compromise at work. But the chemical engineering retained its position, at least in terms of the aims of the society, to promote the profession of chemical engineering. Here's a picture of Davis's Handbook, and one gets a hint in the quote on the right of this idea of unit operations, which was very much the first paradigm of chemical engineering, the idea that there were a limited number of operations that were used to manufacture chemicals, and by studying those operations and working with them, that would lead to improvements in performance. Now, let's get back to South Kensington. This is a picture taken in the 1920s, which includes three of the people that I've either talked about already or want to talk about next. First of all, front and centre is Henry Armstrong. Then we have William Bone, who was already mentioned. And finally, sort of hiding away in the corner, Dudley Newitt. Interestingly, no sign of Hinchley in this photograph. This was a party, I think, at Bone's house to celebrate the publication of a book on combustion. The Zoroastrians was the name they gave themselves as a kind of club, believing that Zoroaster was a fire worshipper, and all these people were interested in combustion. So I want to talk about some of these individuals next. You may recognise this building. This is the Bone building. Bone hated the architecture of the Royal School of Mines, and in particular he hated the idea of wasting money on external decoration of buildings. So what one ended up with was a Bone building which was very functional, fit for purpose, but not very decorative. And of course the building is still there today, so it was built to Victorian standards, and a good building for that. So we've heard that there was a sub-department of chemical technology set up within the chemistry department of Imperial College, which of course had been formed in 1907. But the emphasis on applied chemistry and industrial chemistry continued, and I think Armstrong played a big role in making sure that flavour of chemistry pervaded what was going on here at Imperial. And indeed, the whole charter of Imperial College was about not just knowledge for its own sake, but its application to industry in the original 1907 charter. We've heard about Bone. He lectured on chemical technology from 1909, commuting from Yorkshire to come down and give those lectures, I think. Somebody's shaking their head, which is a worry. And he was appointed a full-time professor at Imperial in 1912. This is John Hinchley, who lectured both here at in the Central Institution and at Battersea College on chemical engineering in the early years of the 20th century. He was appointed to the department in around 1910. He was lecturing from 1910. In 1917, he was appointed Professor of Chemical Engineering here in the department, and he was the first Professor of Chemical Engineering in the University of London. It was a close shave. Indeed, it's argued that the reason that Hinchley was appointed professor was because there were rumours that University College was trying to collect money in order to set up a department of chemical engineering, even though there was an informal agreement between the two colleges that there wouldn't be competition. Nevertheless, the Ramsay Endowment enabled University College to set up chemical engineering, and there's a fine department at UCL these days as well. So Hinchley was appointed as Professor of Chemical Engineering. He was very active in the UK setting up chemical engineering, so he formed a chemical engineering group within the Society of Chemical Industry, but wasn't satisfied with that. He was instrumental in setting up the Institution of Chemical Engineers, which, as we've heard, started in 1922. And he chose not to be president of the IChemE, but instead to be honorary secretary. And he served as honorary secretary of the IChemE for many years. He was clearly a disciple of Lenin. You'll remember that Lenin said that if you wanted to change the world, don't chair a committee, be it secretary, and write the minutes. And so that's what Hinchley did. Great hero of mine, Hinchley, very influential in developing the curriculum of chemical engineering almost from scratch. But the formation of chemical engineering as a discipline was not without people resisting the idea, headwinds as it were. And this quote, which happens to come from Germany, I think is indicative of one attitude towards this emerging profession of chemical engineering. So Duesberg, who was a senior industrialist in the German chemical industry, said, "Nothing, in my opinion, is worse than to make of a chemist or an ingénieur chimiste as is done in France, or a chemical engineer as is very often done in England. I leave to the engineer and to the chemist their respective sciences, but I desire that both work together." So certainly this was a strongly felt attitude in Germany, but it also, I think, had its advocates, certainly in Britain, and so there were quite strong headwinds to the formation of the profession. And if we look at the original coat of arms of the Institution of Chemical Engineers, I think you see some evidence of this. And incidentally, this coat of arms was designed by John Hinchley's wife, Edith, as indeed the portrait that we've seen of him was painted by Edith. She was a very accomplished artist. You'll see in this picture two sides to this coat of arms. On your left, we have chemistry represented, and on the right, engineering. I think the interesting feature of this coat of arms are the birds. And these birds are doves of peace. So what this coat of arms is calling for is for a peaceful marriage between chemistry and engineering. So it's pretty clear to me that the early developers of chemical engineering, the early advocates, were determined that this new profession should happen, but they were also pretty diplomatic. We've seen the change of Armstrong's diploma from chemical engineering to chemistry. We've seen the Society of Chemical Engineers become the Society of Chemical Industry, and we've seen this coat of arms. So I think, these people were truly heroic. They had quite a lot of people resisting what they were trying to do. So now we come to Newitt. We've heard a lot about Newitt already. His work during both World Wars, actually, which was, I think, quite significant in terms of helping to win those conflicts. And I think the key thing about Newitt was that he led the development of the undergraduate program in chemical engineering, which started, as we've heard, in 1937 with 4 students. And Newitt paid tribute to Hinchley, saying that development of that course was really greatly influenced by what Hinchley had done previously. So there's a kind of continuity, Armstrong, Hinchley, Newitt, in the development of the subject. And as we've heard, he was head of department for some 11 years. There's a tradition in this department of heads of departments serving for long periods of time, Neeley. So let's see how that goes. Now, I want now to talk about a couple of individuals who really played a key role in the development of today's chemical engineering. And first of all, I want to present my view of what today's chemical engineering is all about. So what chemical engineering is all about is closing the gap between natural phenomena and engineering solutions. And we do that through two complementary approaches to chemical engineering. So on the one hand, we have chemical engineering science, which is trying to understand the natural phenomena from an applied context and how those natural phenomena can contribute to processes and products. And on the other hand, we have process systems engineering, which starts by looking at the engineering solutions. How do we help engineers design, operate, optimize processing facilities? So to me, there are these two complementary dimensions to chemical engineering. And of course, in a department like this, there's a strong interaction between those two groups of people. Now, Peter Danckwerts, who was a professor here for 3 years between 1956 and 1959, was one of the great proponents of chemical engineering science, not least through his editorship of the journal Chemical Engineering Science. And he was actually my first boss. He moved from Imperial College to Cambridge to take the Shell professorship at the University of Cambridge. And when I almost finished my PhD in 1973, I was recruited by Danckwerts as a very young assistant lecturer in the University of Cambridge. So I got to know Peter reasonably well. Peter actually served in a bomb disposal team during the Second World War. So again, another heroic individual contributing to the war effort. And my other hero of modern chemical engineering is with us this evening, Professor Roger Sargent, who happened to be a PhD student of Dudley Newitt. He was appointed Professor of Chemical Engineering Science in 1962, although he objected to being called a Professor of Chemical Engineering Science. He asked that the name of the chair be changed to Chemical Engineering, and I think that happened. He took over the Courtaulds chair in 1966, and again, Roger served for 13 years as head of department here at Imperial. He was my PhD supervisor, so I should declare an interest at this point. But one of the things that Roger and this department is incredibly famous for is this diagram here. Now, I'm not expecting you to be able to read all the names on this diagram. This is a diagram showing names. On the left-hand side, there's a list of all of Roger's PhD students, all the PhD students that Roger supervised himself. And then we have first-generation PhD students, so that's students of Roger, and so on, all the way down the tree. So you can look at this tree and you'll identify some very famous names. So, for example, one of Roger's early students was Professor Arthur Westerberg, who is now an emeritus professor at Carnegie Mellon University in the United States. One of Westerberg's students was George Stephanopoulos, who is the Arthur D. Little Professor of Chemical Engineering at the Massachusetts Institute of Technology. One of George Stephanopoulos' students was Manfred Merari, who's one of the most highly cited chemical engineers and is professor at ETH in Zurich. And one of Merari's students was Sigurd Skogestad, who's a professor of chemical engineering at Trondheim University. And you'll find all kinds of links of that kind through this family tree. And indeed, there are 7 generations in Roger's family tree now, and over 1,000 PhD graduates, all of whom can trace back their origins to Roger. Now, of course, Roger was a student of Newitt, so this is only a subtree of Newitt's family tree, but I think this is the strongest subtree by a country mile, actually. So I think Roger can reasonably claim, or we can reasonably claim on his behalf, that Roger is indeed the father of process systems engineering. He's the father in the sense that the majority of academic chemical engineers who would see themselves as process systems engineers are on this picture somewhere. Not all of them, but certainly the majority are associated with Roger. So I've talked a bit about some of my heroes: Henry Armstrong, John Hinchley, Dudley Newitt, Peter Danckwerts and Roger Sargent. All of these people played a key role in the development of the chemical engineering that we see today, with process systems and chemical engineering science as equal partners. So I want, in the last few minutes, to talk about some of the challenges that the profession faces in the future, and some of the opportunities as well. So first question is, are we victims of our own success? This is a picture showing the intake to UK chemical engineering departments by year. And those of us who were around in the late 1990s were very worried about the future of the discipline, because applications to chemical engineering were going south big time. But something happened in 2000, 2001, and actually this graph is not completely up to date. By now, we've more than tripled the number of young people choosing to study chemical engineering at UK universities. And one question is there going to be enough work for these people? My personal view is yes, there will be, and I'll say a little bit about why in a moment. But it is an interesting and, in some cases, very significant question for some of the members of the audience. Neil mentioned that I spent 3 years in the Department for Business Innovation and Skills, working at least some of the time for Vince Cable. One of the things Vince asked me to do was to look at engineering skills in the UK. Were we producing enough engineers? What could be done about that? And one of the graphs in the report that was produced is this one, which shows that in terms of gender balance, engineering in the UK is the worst in Europe. Only 8%, I think, of people practicing engineering turn out to be female. And of course, Europe isn't the benchmark in terms of gender balance in engineering. There are other parts of the world which do much better than any country in Europe. I think we really do need to embrace this challenge and do something about it. Now, of course, we can be quite smug, because if you look at the proportion of women in different engineering disciplines, you find that we're streets ahead. You know, we're operating at around 25% females. Why not 50% is what I ask, whereas others are in the sort of 5 to 15% range. But the worrying thing about this graph is that all the lines seem to be horizontal. So we really do, I think, need to embrace the challenge of encouraging more young women into engineering in general and into our own profession in particular. Why do I think there'll be enough work for chemical engineers to do, even though we've tripled the supply? Well, there are some really challenging issues where a combination of a good, broad knowledge of science and problem solving through systems thinking will really make a difference. And I've listed some of them here. The energy, food, water nexus. You know, if we use more land for producing feedstocks for biodiesel, what impact does that have on food? If you look at the amount of water that a food company like Nestle uses, there must be huge opportunities to improve the utilisation of water in those companies, and that's good, solid chemical engineering, and so on and so on. So there is no shortage of challenges, and I've always said that chemical engineering is the best academic discipline to study if you're interested in not just in science for its own sake, but the application of science to address real problems. And I continue to believe that, and I continue to think that chemical engineering can make a huge contribution to each of these areas and to other areas of challenge that we face. So, what are my conclusions? Well, thanks to the efforts of the heroes that I've talked about, and others, it's fair to say, I believe that chemical engineering is now a fully fledged discipline. We've earned our spurs. People are no longer questioning the need for chemical engineers. And as you've seen, we're on an upward trajectory in terms of recruitment. And the really strong thing about chemical engineering is this combination of a strong science base with systems thinking. And it's those two things together that are our unique selling point as a profession. So it's now time, ladies and gentlemen, to spread our wings and address as many of the opportunities that are out there as we can. So thank you for your attention, and I look forward to trying to answer any questions you might have. Thank you.